Traveling through time sounds like something out of a sci-fi novel, right? But according to modern physics, this idea isn't entirely out of the question. So is it really possible to travel to the future or the past? What if the answer is a no? Are there any theories out there that think time travel could still be possible? Let's dive into both the idea of traveling to the future and the past, and explore what the scientific community really thinks about time travel right now. It's traveling to the future. Traveling to the future has actually been proven to be possible. Einstein's theory of general relativity tells us that time isn't absolute. It actually changes depending on speed and gravity. Since the mid-20th century, scientists have conducted tons of experiments to back this up. When objects move at incredibly high speeds, like astronauts or satellites, they experience time more slowly compared to those on the ground. It's like they've actually jumped into the future. This cool phenomenon is called time dilation, and it's the only form of time travel that's been proven so far. Isn't that mind-blowing? A simple example is the expansion of the ruler week. This expansion shows that due to time dilation, the pointer of a gyroscope, rotating at high speed close to the speed of light, moves slower than a stationary pointer. In other words, the pointer that's spinning fast actually travels less distance compared to the one that's at rest. For example, a stationary clock ticks 1 second every second, while a clock spinning at high speed ticks only 0.99989 seconds each second. That means the fast-spinning clock is lagging behind the stationary one by 0.00011 seconds. Sure, that difference is tiny, but it shows that even when you're moving at breakneck speed, time can still slow down a bit. Imagine a person sprinting at 60 miles per hour in a 100-meter dash, finishing the race in just 11.18 seconds. At the same time, a spaceship traveling at 0.8 times the speed of light takes about 11.14 seconds to reach the finish line. This means that, compared to the ground, time on the spaceship is slightly delayed. Isn't that wild? The faster you go, the more time seems to stretch, right? So, if a spaceship zooms fast enough, the folks on board can actually feel time slowing down or even stopping. It's wild to think that theoretically, if you get close enough to the speed of light, travelers heading to distant galaxies could wrap up their journey and come back to Earth in what feels like a blink. Meanwhile, back on Earth, people might have lived through hundreds or even thousands of years. Isn't that mind-blowing? Traveling back in time? The theory of time travel goes back to the concept of wormholes. Wormholes are theoretically possible shortcuts in space-time, with two openings located at different points in time and space. So, if we could somehow traverse a wormhole, we could reach a specific moment in the past. The thing is, to keep a wormhole stable and actually usable, we need something called exotic matter, the catch. This stuff hasn't been reliably created or observed yet. Another theory is the closed time-like curve CTC, which requires extreme conditions like cosmic strings or rotating cylinders, things that are pretty hard to pull off in real life. Plus, some scientists think time travel could lead to time paradoxes like the grandfather paradox. Here's how it goes. If someone goes back in time and kills their grandfather, then they shouldn't exist, right? Otherwise, how could the grandfather have fathered their parent in the first place? This question still doesn't have a definitive answer, but it's generally believed that time travel could lead to a bunch of unpredictable consequences. And it might even result in the destruction of the entire universe. Despite that, theories about time travel still exist. For instance, back in 2019, an American theoretical physicist named Harold White came up with this intriguing idea of using artificial wormholes for time travel. In 2023, two Russian scientists proposed a scheme that utilizes magnetic fields, which doesn't require exotic matter and sidesteps issues like the grandfather paradox. All in all, the idea of going back in time is still just a theory. Right now, there isn't any method of time travel that's been proven or verified. Warp drive is an ultra-cool concept from science fiction. Just imagine a spaceship racing through a warp bubble, breaking the speed of light and unlocking endless possibilities for interstellar travel. This technology never fails to spark our imagination about the future of science, and it's truly exhilarating. Faster than light speed refers to a velocity that exceeds the speed of light, which is approximately 186,000 miles per second, or 300,000 kilometers per second. This speed is defined according to Einstein's theory of relativity and is currently considered impossible to achieve in modern physics. as the energy required for any object to approach the speed of light would be unmanageable. According to Einstein's theory of special relativity, nothing can move faster than the speed of light. But here's the cool part. Warp drives don't actually break that rule. They don't require objects to exceed the speed of light at all. Ah, how awesome is that? Are in specific areas. Space is distorted, allowing us to reach our destination through accelerated motion. This method enables us to arrive at our desired locations much faster. In 2012, an American physicist named Robert Bowe came up with this really intriguing idea about using wormholes to create a warp drive. The basic concept is pretty cool. Imagine using artificial wormholes as shortcuts through space to transport a spaceship and its crew to their destination. How wild is that? Wormholes connect the location of the spaceship and its destination, allowing the ship to reach its goal in no time. However, as of now, no stable natural wormholes have been discovered, let alone any artificial ones. In 2017, a British scientist named Dave Burns proposed a warp engine concept using quantum entanglement. Quantum entanglement refers to the phenomenon where two or more quantum particles influence each other, even when they are separated by vast distances. Using entanglement allows for the swapping of positions between two parties, making superluminal communication and transportation possible. In theory, a warp drive powered by quantum entanglement could enable rapid communication and swift transportation of people. However, it hasn't been proven to be feasible just yet. The biggest challenge? Energy and navigation. Traveling through time and space requires an immense amount of energy. Plus, navigating through time is super complicated because the Earth and the universe are always on the move. If you mess up your coordinates, you could end up traveling to a completely empty part of the universe. How wild is that? Summary. Traveling to the future is a well-accepted fact in physics, but going back in time, it's still a whole different ballgame filled with challenges and mysteries. Right now, scientists are diving deep into how to stabilize wormholes, create exotic matter, and tackle those pesky time paradoxes. Exciting stuff, huh? Maybe in the near future, humanity will really be able to achieve the ability to travel through time. So, have you ever thought about what time travel would really be like? Would you rather zip into the future, surrounded by mind-blowing technology? Or would you want to step back into the past, wandering through majestic kingdoms with stunning palaces? Just imagine experiencing those unique journeys and thrilling adventures across different eras. If there were a time machine available, would you be brave enough to give it a shot? References. Ives, J. 1952. The Theory of Special Relativity. London, Methuen Publishing. This book provides a thorough exploration of Einstein's groundbreaking ideas, making complex concepts accessible and easy to understand for the general reader. Stephen Hawking's groundbreaking book, A Brief History of Time, was published in 1988 by Bantam Books in London and dives deep into the fundamental concepts of the universe. It covers topics like black holes, time travel, and the nature of the cosmos, presenting complex theories in a way that's easy for everyone to grasp. Hawking's work has inspired countless readers to ponder the mysteries of existence and our place in the universe. For anyone curious about physics and cosmology, this is definitely a must-read. Tipler, F.J., 1974. The Physics of Time Travel. This groundbreaking work, published by W. H. Freeman in New York, delves into the captivating scientific theories surrounding the concept of time travel, skillfully blending physics with imaginative possibilities. White, H. 2019. Al-Kabir, R. A. ed. Wormholes in Spacetime dives deep into the captivating concept of traversable wormholes, exploring their theoretical foundations and the fascinating implications these extraordinary structures could have for future interstellar travel. It truly sparks the imagination about the limitless possibilities of the universe. In 2017, D. Burns explored this fascinating concept of a warp drive engine powered by quantum entanglement, which could completely transform the way we think about space travel. The idea suggests that by harnessing the mysterious properties of quantum physics, we might one day achieve faster-than-light travel. Just imagine zipping through the universe like something out of a sci-fi movie. It's such an exhilarating possibility that sparks endless imagination, don't you think? Hope you all love diving into the world of time travel and exploring the past. If you enjoyed this video, Don't forget to hit that like button, subscribe, and ring the bell so you won't miss any updates. Catch you next time. The Curious Sister at Today-Sandy channel will regularly update you with fun videos, so be sure to subscribe. Thanks for all your support.